Hi, welcome back. Here's another application of systems of linear equations. So this is another application that's in section 1.3 of our textbook. Network analysis. This is something that engineers do all the time. So this is a simple example of a network. A network has branches, multiple branches coming out of and going into junctions, right? And the basic property of all networks is that the flow in always has to equal the flow out. So this network that I have here could represent water, sewage, the amount of water or liquid. It could be electricity. The amount of electricity coming into the junction has to equal the total amount of electricity going out. So, for example, if we have, let's say this is water. If we have 16 gallons per minute coming into the junction, and we know that the two branches have x1 gallons per minute and x2 gallons per minute, respectively, coming out, the basic property of networks says that x1 plus x2 has to equal 16. Okay, so we're going to use that property to set up and solve systems of linear equations. So let's look at this example. In this example, it says the flow of traffic in vehicles per hour is given by this network. Okay, so that looks like there's 4 junctions and 1, 2, 3, 4, 5, 6, 7, 8, 9 branches. Okay, and the problem asks us to find x1, x2, x3, x4, and x5. So what we're going to do is let's first label or name the 4 junctions. So I've got junction 1, junction 2, 3, and 4. Now for each junction, I'm going to write down an equation representing the balance in the flow in and the flow out of that junction. So for junction 1, we see that we have 400 vehicles per hour flowing in to the junction, and then we have 400 plus x2 flowing in, and then flowing out we just have x1 vehicles per hour. So I can write down x2 plus 400 equals x1. That's for the first junction. For the second junction, I have x1 plus x3 has to equal 600 plus x4. So coming in is x1 plus x3, and going out is 600 plus x4. And then the third junction, we have coming in is 300, but going out is x2 plus x3 plus x5. And then the fourth junction, going in is x4 plus x5, and leaving is just 100. So now we've set up 4 equations in 5 unknowns. So let's get these into sort of the standard form where all of our constants are on the right. So just rearranging the terms, I get x1 minus x2 is equal to 400, x1 plus x3 minus x4 equals 600, x2 plus x3 plus x5 is equal to 300, and x4 plus x5 equals 100. So remember, we have 5 unknowns, 4 equations. Let's set up a matrix. So we're going to have 4 rows and 5 columns. So the first row is going to be 1, -1, 0, 0, 0, 400. The second row is going to be 1, 0, 1, -1, 0, 600. The third one is going to be 0, 1, 1, 0, 1, 300. And the last one will be 0, 0, 0, 1, 1, 100. And now we're going to do Gauss-Jordan elimination. And I encourage you to learn how to use wolframalpha.com, which I showed you in the previous video. Or if you're comfortable using graphing calculators or other technology, you can get this into reduced row echelon form using technology. And so I did it on wolframalpha.com. And in reduced row echelon form, I got the following: 1, 0, 1, 0, 1, 700, 0, 1, 1, 0, 1, 300, 0, 0, 0, 1, 1, 100, and then a row of zeros. And notice this is reduced row echelon form. We only have 2 leading, we have 1, 2, 3 leading ones, and all the other entries in the columns that have leading ones, all the other entries are 0. So this is in reduced row echelon form. And so now we can translate this back. Those are my 3 leading ones. Now I'm just going to make a note of who's free and who's not free. So the leading ones are not free. Those are our dependent variables. So x1, x2, and x4 are not free. They're dependent on the free variables. The free variables are x3 and x5. The columns that do not have leading ones. Those represent the free variables. So now we can write down the equations. So the first equation was x1 plus x3 plus x5 equals 700. The second one was x2 plus x3 plus x5 equals 300. And then the last one was x4 plus x5 equals 100. And solving for the dependent variables in terms of the free variables, we get x1 is equal to 700 minus x3 minus x5. The second one gives us x2 is 300 minus x3 minus x5. And the last one gives us x4 is equal to 100 minus x5. So notice our 2 free variables are x3 and x5, which we had noted previously. So now let's use parameters. So let's let x3 be s and x5, let's call that one t. So now the solution is going to be x1 is 700 minus s minus t. x2 is 300 minus s minus t. x3 is s. x4 is 100 minus t. And x5 is t, where s and t are both any real numbers. So 2 free variables, 2 parameters, and then we have 3 dependent variables. All right, so that's a simple network, and we analyzed it. Okay, so I will see you in the next video.